For the first question, we're going to use the multiplication law for logarithms. So we've got two logarithms that we're adding together with the same base, which means we can do log of base 3 of 6 multiplied by 7. So that is equal to log base 3, 6 multiplied by 7 is 42. For the next one, we're going to use the division law. So again, the reason why we're able to use the division law is because they've got the same base there. They've got a base of 5. So we're going to do log base 2 of 15 divided by 3. So that's log base 2 of 5. For part C, we're going to apply the power law to both parts of the expression first, because we've got coefficients in front of our logarithms. So if we've got 2 log base 5 of 3, that is the same as log base 5 of 3 squared, and then we're adding log base 5 of 2 to the power of 3. So when we've got the number in front of our logarithm, we can raise the number here by a power of that number. So once we've done that, we're going to rewrite it. So 3 squared is 9, and 2 to the power of 3 is 8. We've now got two logarithms that we're adding together with the same base, with a base of 5. So we can now apply that multiplication law that we did in part A. So we've got log base 5 of 9 multiplied by 8, which is log base 5 of 72. For the last one, we've got two logarithms here that we're subtracting. Again, with this logarithm here, we've got a number in front of it, so we're going to raise a half to the power of 4. So we've got log 10 of 3. I'm going to subtract log base 10 of a half to the power of 4. So we've got log base 10 of 3 subtracting log base 10 of 1 over 16. So we've now got two logarithms, we're subtracting them, they've got the same base, so we're going to use the division law. So we're doing log base 10 of 3 divided by 1 over 16. Now remember, when we're dividing fractions, so when we divide a whole number by a fraction, we multiply the whole number by the reciprocal of that fraction. So we're doing 3 multiplied by 16 here, and we get log base 10 of 48. We're now going to go the opposite way, so we're given single logarithms and we want to write them as separate logarithms, so sums of logarithms or subtractions. So if we've got log base a of x squared y z cubed, that is equal to log base a of x squared plus log base a of y plus log base a of z squared, because we've got the multiplication law here with base a. And then going to simplify this further using the power law. So if we've got x squared here, that is the same as 2 log a x. We've got log a y, and then, sorry, that should have said cubed. We're going to add 3 log a z. For part B, we've got the division rule here. So we've got log base a of x, subtract log base a of y cubed. Now again, we want this in terms of log ax, log ay, so we're going to have to use the power law for this term here. So that is the same as log ax subtract 3 log ay. Part C, again, we're going to use the division rule here. So we've got log base a of x root y, subtract log base a of z. because x root y is the numerator here and z is the denominator. So we're doing x root y divided by z in that bracket there. Then you can see with this logarithm here, we've applied the multiplication rule because we've got x multiplied by root y. So I'm going to rewrite that logarithm there as log ax plus log a root y, and then subtract log a z. Now the question asks us to write our answers in terms of log ax, log ay, and log az. We've currently got it in terms of log ax, log a root y, and log az. I'm going to use my laws of indices to write this as log in terms of log ay. So root y is exactly the same, plus, as y to the power of a half. And then I can now use the power law and bring that half to the front of the logarithm. So that's equal to log ax plus a half log ay subtract log az. The last one, again, we're going to apply the division rule here. So I've got log ax subtract log a to the power of 4. Now we've got that's equal to log ax subtract 4 log a of a, because I've used the power rule there. Now if we remember, log a is equal to 1. So we're going to have log ax subtract 4 as our answer. For this example, we are given an equation in terms of x involving logarithms. So we want to manipulate this logarithm expression to get it into a linear equation in terms of x that we can solve. So we've got log base 10 of 4. I'm going to use the power rule here and change that logarithm into log base 10 x squared is equal to 2. I've got two logarithms here that are added together with the same base, so I can use that multiplication law, and I get log base 10 4x squared equals 2. Now if we rewrite the logarithm using powers, we know that 4x squared is equal to 10 to the power of 2. The reason why we know this is because log an equals x is equivalent to a to the power of x equals n. That's what we looked at last lesson. So here we had a base of 10, so that's why we've got a 10 there, of 4x squared is equal to 2. So that means 10 squared is equal to 4x squared, using this rule of logarithms here. I can now square 10 and I get 4x squared equals 100, divide by 4 and I get x squared is equal to 25. So then I need to take the square root of 25. So we get 5 and negative 5. Now, if we actually look at our equation, we've got that that x is n in terms of this logarithm here. So if we've got a to the power of x equals n, anything raised to a power is always positive. So we have to take our positive value of x and ignore our negative value, because anything raised to a power is always positive. So the number we have in the logarithm here always has to be positive. Okay, for this one we're going to use the division rule because we've got two logarithms with base 3 and we're subtracting them. So we get log base 3 of x plus 11 over x minus 5 is equal to 2. So then again, if we use the fact that log an equals x implies that a to the power of x equals n, we can rewrite this using powers. So we've got a here is equal to 3. So we know that 3 to the power of x, which is equal to 2 here, so 3 squared, that is equal to this algebraic fraction here. So x plus 11 over x minus 5. So just using this rule that we looked at last week. 3 squared, that is equal to 9. So we've got 9 is equal to x plus 11 over x minus 5. And we've just got an algebraic fraction to solve. So we're going to start by multiplying by the denominator, which is x minus 5. Multiply out this bracket, expand that bracket. I'm going to start by subtracting x from each side. I'm going to add 45 to each side. And then divide by 8 on each side, and we get x is equal to 7.